When Admiral Richard Byrd explored the South Pole, he didn't know if he would ever see civilization again, but he had a beacon home because NavCorp Global Link was there. When the crew of Apollo 11 journeyed to the lunar surface, we were there with the essential navigational link to help them find their way home. Trust lies at the heart of every journey. At NavCorp, we build trust every day by understanding the critical nature of every mission and by developing innovative solutions that help our customers complete their missions successfully. Throughout the world, one navigational company offers total capability, on land, at sea, in the air, and across the electronic and communications environments. That company is NavCorp. For over 75 years, NavCorp has designed, built, and maintained systems for the defense, aerospace, automotive, monorail, nautical, and robotics industries. We are the premier navigational supplier with more than 6,000 employees in over 20 countries, providing solutions in air and naval defense, artificial horizons, autopilot systems, intelligence and security, surveillance and reconnaissance, automotive accidents avoidance, gesture-based user interfaces, anti-roll devices and stabilizers, virtual reality solutions, and robotic controls. Working collaboratively, NavCorp ensures its partners have the capabilities they need when they need them. We also work globally with over 2,600 companies in our supply chain, and we invest heavily in research and development, spending over $10 for every 100 of revenue. Our culture is based upon creating partnerships with our customers, our suppliers, and our people. Operating across 5 continents with customers in more than 100 countries, NavCorp offers global capability. It is this capability we can call on to ensure that our customers have the best services and support worldwide. At NavCorp, our services, our performance, and our people combine to give our customers a real advantage, with innovative navigational systems to give pilots the vision and information they need to ensure a safe and successful flight. NavCorp has been in the business of making gyroscopes and their related applications for over 75 years. The NavCorp Education Division, NED, has imported 2 technologies from its other divisions, the Electronics Division and the Gyroscopic Division, to create its newest product, the DSM 3000. Production for the DSM 3000 is an interesting process that occurs in 2 parallel paths, the gyroscope itself and the electronic base. In the assembly of the gyroscope, there are 2 rolls, the flywheel initial ring assembler and the final ring assembler. At the same time, the electronic base is assembled in a parallel path with 3 rolls, the electronic assembly, motor assembly, and the base assembly. The electronics assembler takes the incoming printed circuit boards and attaches the necessary components, the resistors and IR sensors. After electronics assembly, the motor assembler attaches the motor and motor housing to the top of the base and the printed circuit board. Finally, the base assembler finishes the final assembly by attaching the remaining support posts to connect the top and the bottom of the base. The DSM 3000 gyroscope is controlled and powered by a printed circuit board, also known as PCB, incorporated into its base. A printed circuit board is simply a thin board, usually fiberglass, on which electronic components are mounted. The board is printed with a thin layer of metal traces to provide connections between the components. The DSM 3000 PCB has 4 quadrants: signal, thermal, regulator, and drive. The first 3 quadrants, signal, thermal, and regulator, provide information to the microprocessor, which in turn provides the necessary operating instructions to the drive. A microprocessor is simply a chip that can process programs, remember information, and perform calculations. The role of each of the quadrants is as follows. The thermal module controls the heat produced by the power source, as well as the heat generated by the motor itself, enabling the microprocessor to protect the components from excessive heat. If the voltage regulator gets too hot, the thermal quadrant will shut off the signal to the microprocessor, thereby shutting down the motor. The signal quadrant ensures the signal coming out of the microprocessor is correct to control the motor speed and the LED lights. The regulator quadrant determines the correct voltage input into the microprocessor to effectively power the motor and set the flywheel speed. The drive quadrant translates the power signal from the microprocessor to the motor to tell the motor to run.